Hi, I'm Mr. Miller, and this is a lesson on sum, difference, and double angle identities. So before we can apply the identities, we need to prove their validity. So let's consider the following in order to determine expressions for sine of alpha plus beta and cosine of alpha plus beta. In this diagram, what we can conclude, since this is angle alpha plus beta, and this is a rectangle, this angle is alpha plus beta because this pattern, this Z pattern, these two angles, the angle ABF and the angle AFD, they are called alternate interior angles. So alternate interior angles, according to the parallel line theorem, are equal to each other, which means this being alpha plus beta makes that alpha plus beta. Now, the other way to prove it to yourself is to consider this 90-degree angle here. And so this small angle is 90 minus alpha plus beta combined. And if you consider the three angles in the triangle, which have to add up to 180, 180 minus 90 gives you 90. And then taking away the 90 minus alpha plus beta leaves alpha plus beta left over here. So in any case, this angle is definitely alpha plus beta. So from there, the sine of alpha plus beta would be the opposite side over the hypotenuse. So that's AD over 1, which reduces to just AD. So I'm going to label that as sine of alpha plus beta. Next, if you look at the sine of just beta, this is the angle beta, you get the opposite side over the hypotenuse, which is EF over 1. And so EF is just sine beta. Next, if you consider the fact that this angle is 90 minus alpha, you can determine that this angle here, the angle FEC, is also alpha. So you take 180 degrees, take away 90, you're left with 90, and take away 90 minus alpha, you're left with just alpha here. Or the other way to consider it is alpha plus 90 plus 90 minus alpha gives you 180, and that is a straight angle, so that makes sense. So we can look at the cosine of alpha, and the cosine of alpha would be the adjacent side here over the hypotenuse sine beta. And if you cross multiply, you can get that EC is cosine alpha times sine beta. So we can label that here. Now the cosine of beta is also AE over 1. So this angle beta, we've got the adjacent side over the hypotenuse, so AE over 1, which means AE is equal to cos beta. And now the sine of alpha can be written as BE over cos beta. So the sine of alpha would be the opposite side BE over the hypotenuse cos beta. And now if we cross multiply to solve for BE, it's sine alpha times cos beta. So I can write that here. Now, the side AD is opposite to the side BC, and opposite sides in a rectangle are equal to each other. So BE plus EC would be equal to AD. And so for that reason, sine of alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta. And this is the addition identity for sine. Next, if you look at the cosine of alpha plus beta, here's the angle alpha plus beta. This is the adjacent side over the hypotenuse, which makes DF equal to cosine of alpha plus beta. And if we look at the sine of alpha, it is, sine of alpha is the opposite side over hypotenuse, so CF over sine beta. And if you cross multiply, you get that CF is sine alpha sine beta. So we can label that length here. Next, the cosine of alpha is the adjacent side to this angle alpha, which is AB, over the hypotenuse cos beta. And if we cross multiply, we get AB is equal to cosine alpha times cosine beta. So I can label that length here. Now, the length from D to F, of course, this side length is the same as this side length, so opposite sides in a rectangle are equal, which means that this length DF is equal to the full length from A to B if we take away from C to F, which means that cosine of alpha plus beta is equal to cosine of alpha cosine beta minus sine alpha sine beta. And this is the addition identity for cosine. So here they are, the two sum identities. Sine alpha plus beta is sine alpha cos beta plus cos alpha sine beta. And the cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Now, you can get the tangent addition identity just by doing a substitution into each of the sine and the cosine identities, because we are aware of this quotient identity. So when you do a substitution there, you will get sine alpha cos beta plus cos alpha sine beta over cosine alpha cosine beta minus sine alpha sine beta. And if we divide the top by cosine alpha cosine beta, and we divide the bottom by cosine alpha cosine beta, then this will simplify to tangent of alpha plus tangent beta over 1 minus tangent alpha tangent beta. So notice that the cosine beta divides out, sine alpha over cosine alpha gives you tan alpha. The cosine alpha divides out, you've got sine beta over cosine beta, which is tangent beta. In the denominator, the cosine alpha divides out, the cosine beta divides out, you're left with 1. Here, sine alpha over cosine alpha is tangent alpha, and sine beta over cosine beta is tangent beta. So, although you'll only be assessed for my Pre-Calc 12 students on sine and cosine addition identities, this is just a little bit of a bonus for you, because you may run into that in future classes. All right, now we can use these to get the three angle difference identities. So sine of alpha minus beta is sine alpha cosine negative beta plus cosine alpha sine negative beta. Well, if you take the cosine of negative beta, you actually get the identical thing as cosine of beta due to the symmetry of the cosine function about the y-axis. And if you take the sine of negative beta, you actually get the opposite of sine of positive beta because of its symmetry as well. And so there's your difference identity for sine. For cosine, the difference identity goes like this: cosine alpha times cosine negative beta minus sine alpha times sine negative beta. And so again, when you're taking the cosine of a negative angle, you get the same as the cosine as the equivalent positive angle. And sine of negative beta is the same thing as negative sine beta. And so you're instead adding this last term. So just in case you weren't sure about the strategy here, what we did is we treated the alpha minus beta as alpha plus negative beta, and that way we were able to do a substitution and a simplification from there. Now for tangent, if you are substituting in a negative beta for the angle, then what you get is the following. So the tangent of negative beta is the same as negative tan beta, and so it just changes the sign of the second term on the top and the second term on the denominator. So that's that identity. So now we've done sum and difference identities. Now when alpha and beta are equal to each other, here are the double angle identities. So sine of 2 alpha is like sine of alpha plus alpha, which means sine alpha cos alpha plus cos alpha sine alpha. Those two terms are the same, so it's actually 2 sine alpha cosine alpha. And the double angle formula for cosine goes like this. Cosine of alpha plus alpha is cosine alpha minus sine alpha sine alpha. So that's cosine squared alpha minus sine squared alpha. Now there are some different forms that you can work with if you like. What you can do is you can replace the sine squared alpha with 1 minus cosine squared alpha, and that leads to 2 cosine squared alpha minus 1. Or you could replace the cosine squared alpha with 1 minus sine squared alpha, which gives you 1 minus 2 sine squared alpha. So depending on the situation, if you want to have everything in terms of sines, you could use this. If you want to have everything in terms of cosines, you could use that. And if you're okay with a combination of those things, then you could use this one. So there are actually 3 versions of that double angle identity for cosine. And the double angle formula for tangent goes like this. Tangent of alpha plus alpha is tangent alpha plus tangent alpha over 1 minus tangent alpha tangent alpha. So it's 2 tangent alpha over 1 minus tan squared alpha. All right, so let's see if you can recognize, for example, number 1, how to write this as a single trigonometric function evaluated at an angle. So which of the identities looks like cosine something else, minus sine something else? And you should recognize that that is like the cosine of 60 degrees plus 50 degrees, which would be the cosine of 110 degrees. And so now here's another one. 5 pi over 12 is not a special angle, but it is the sum of 2 special angles. So this is the tangent of pi over 4 plus pi over 6. That's how each of these reduces. So now we use the addition identity for tangent. And we can evaluate each one of these. So the tangent of pi over 4 is 1. The tangent of pi over 6 is 1 over root 3. And again, the tangent of pi over 4 is 1. Tangent of pi over 6 is 1 over root 3. Now, this is evaluated exactly, but it's not simplified. So if I go to simplify, here's what I would do. So first of all, I would write the 1 as root 3 over root 3, add it together with the other term. So I get root 3 plus 1 over root 3. And in the denominator, I have root 3 over root 3 minus 1 over root 3. And so here's what we get. Now, division of fractions, we flip and multiply. And so you can see that the root 3 factor will divide out, and you're left with root 3 plus 1 over root 3 minus 1. Now, at this point, we've got an irrational denominator. So to rationalize it, we multiply by the conjugate. And here's what you get as a result. So root 3 times root 3 is root 9, which is 3. 1 times 1 is 1. And you also get 1 times root 3 and 1 times root 3. That's 2 times root 3. This is a difference of squares, so 3 minus 1. That gives you 2. The 3 plus 1 gives you 4, so that's simplified as much as possible there. Then you do the final division, and you get 2 plus root 3. Final question, an application for physics. So you have a formula in physics for determining the, so this is a formula for the distance of a projectile with an initial velocity of v naught, where theta is the angle of trajectory and g is the acceleration due to gravity. And what you'll notice in this formula is that 2 sine theta cosine theta is our double angle formula. And it's the double angle identity for a sine of 2 theta. So if you like, this simplifies a little bit in that way. Now the question here is, what is the angle that will maximize the distance that the projectile will go? So the maximum distance that it can go is when this sine factor is going to be 1. That's the biggest it can be. And of course, the angle that corresponds to that is an angle of 90 degrees. That's the 2 theta being 90 degrees. So that means theta itself will have to be 45 degrees. So if you've ever thrown a baseball or kicked a soccer ball or launched a rubber band in the air, those projectiles, if you have a certain amount of initial velocity, the way to maximize the distance that it's going to go is to aim it at 45 degrees above horizontal. So that completes this lesson on sum, difference, and double angle identities. Thanks for watching and have a great day. Bye.